Well, here's another test for you on the steering and suspension A4. I'm going to do this one a little different today. What I'm going to do is I'm going to have the answers at the end instead of right after each question. That way you'll have more of an idea of how you did on the test. And you know, once again, I try to put interesting illustrations in there that I created and that kind of stuff. So let's see if we can jump into question number 1. Why might an EPS vehicle with, I messed the wording up, show intermittent heavy steering effort during low-speed parking maneuvers? Okay, what you need to do is forget about this one. That's really something how I can read that question over and over and over and over again and still miss that word until I'm finally doing it. Worn tie rod end, low system voltage, loose serpentine belt, or failing torque sensor. Question 2. A vehicle pulls to the left after a curb strike. Which alignment angle is most likely out of specification? Positive camber shift, increased rear toe end, reduced left caster, or a toe out condition? Question 3. A customer hears a clunk noise when braking and accelerating. What would be the most likely cause of that? Loose stabilizer link, worn ball joint, control arm bushing, or weak strut mount? Question 4. A vehicle has no EPS assist after startup, but assist returns after driving a short distance. Which condition is most likely? Weak engine mount, loose wheel bearing, low system voltage, or worn steering rack? Question 5. A vehicle shows this wear on both sides, but without tread feathering. Are both sides towed in? We got thrust alignment issues, positive caster, or positive camber. You can see the wear on the tires out here, and some here is almost down to the cords. All right. Question 6. A shimmy is felt at highway speeds, but the tires are all balanced. Soft rear springs, weak hood latch, loose control arm, or steering wheel pad? Question 7. EPS sets an overheating DTC. Most likely cause would be A. Binding steering rack, B. Worn serpentine belt, C. Low engine coolant, or D. Weak battery voltage? Question 8. Which alignment condition is most likely on this vehicle? Increased caster angle, improper thrust alignment, positive camber angle, front tires towed out? Question 9. A vehicle nosedives excessively during braking. You got weak front struts, loose stabilizer link, weak rear shock, worn tie rod end. Question 10. EPS vehicle steering wheel doesn't want to return to center after turns. Possible cause: weak sway bar bushing, loose battery terminal, worn wheel bearing, or reduced caster angle? All right, now we move into the answers. This one's not going to take you a long time, but we will have some more discussion on the answers than we had on the questions for obvious reasons. All right, so you're going to have a failing torque sensor is the most likely cause of that. You can see you got these the traces that you get on your scan tool. Torque sensors look a whole bunch of different ways, and they're mounted in various different places. Some of them are mounted right on the rack. Some of them are mounted right under the steering wheel on the column. Some of the electronic steering systems have got a motor and a worm gear and all right up under the dash, like a lot of your GM cars in the 2000s range. And but more and more common now is the steering rack with the motor and stuff built onto the rack. But a lot of the times they'll try to put all of that stuff together. They'll put the torque sensor and everything all together on the rack, so there's only thing you'll have up there under your steering wheel will be your clock spring or whatever. So the torque sensor is critical because it measures driver steering input. If it fluctuates, you can read the words. The control module cannot correctly command assist, and it will cause intermittent heavy steering. But this is just one of many different kinds of torque sensors. I mean, there's no end to the pictures you could put of torque sensors. Vehicle pulls to the left after a curb strike, most likely is reduced left caster. If the caster angle is steeper on one side, it's going to probably pull in that direction. A less positive caster is weaker self-centering on that side. It drifts toward that side. More positive caster is stronger self-centering, and it drifts away from that side. You might remember I was telling you last week that positive camber and negative caster, if they're on the same wheel, even if everything is within specs, will cause a vehicle to drift to the side when it's got the most negative caster and most positive camber. And that will confuse some people that depend too heavily on the numbers on the screen. You know, if they have everything in the green, they say, why is it still pulling? Everything's in the green. Well, you got to have that little tweak there. See, if you got, that's what you call a tolerance stack up. You got camber that's slightly too positive, you got caster that's slightly too negative, but not so that it, you know, the machine catches it as something that's a problem. Understanding that's important. Customer hears a clunk noise from braking and accelerating. Warn. I mean, that's a control arm bushing thing. Of course, usually they'll squeak. That's me changing a control arm bushings on a Dodge control arm. Most of the time, people will just replace the control arm. But in this particular case, because I was teaching, I said, okay, guys, you can replace the whole control arm, but this is how you replace the bushing. You can typically buy control arm bushings for a lot of the vehicles, like some of your Fords. You can get control arm bushings for them, but they're really, you got to go through special procedures and annoying aggravation to change them. And you can see what I did on this one here. This is actually a video that I've got on my YouTube channel that I downloaded and inserted into this. And so most of the time, though, when you've got control arm bushing issues, if they're going to clunk or something like that when you're taking off or stopping, they're going to be worn completely out where there's nothing left. Usually what they start to do is squeak when you're going over bumps and stuff. And that typically is because the rubber has broken loose from the usually the inside sleeve, you know, that the bolt goes through, and it's being held and as the control arm goes up and down, it's basically sliding that rubber on that inside piece instead of it being bonded to it. And that's usually what control arm bushings will do. But if they're worn completely out or where all the rubber is gone, you'll hear clunk noises. Vehicle has no EPS assist after startup. That will be low system voltage. All of these electronics, if they see low system voltage, they will not do their job until the system voltage comes to an acceptable level. And EPS is like that too, typically. You know, there's slightly different algorithms from one vehicle to the next, but they often disable assist when voltage is below a threshold, like I say, like any other module will do. Once the alternator raises system voltage, the module re-enables assist. Engine controllers, if the voltage is too low, I know I've seen this on Fords. We had I was on your Power Stroke diesels. If your battery voltage it drops below about 7.5 volts when you're spinning it over, even if everything else is just like it's supposed to be, that battery voltage below that threshold, it will not operate the injectors. And a regular gas burning Ford, if the battery voltage, like you'll spin it over and it may sound normal, but if that battery voltage drops below about 8 or 7.5 volts or something like that, or 8 volts, it's going to vary from platform to platform. It won't operate the injectors. So you can have a no start, even though it sounds like it's spinning normally. If you monitor the voltage, you're going to find out that sometimes you'll have a no start, or you'll have a module that's not working just because it doesn't have enough voltage. I saw an airbag module, not an air suspension module, that was offline because the voltage it was reading was only 8 volts in spite of the fact that there was 12 volts going to the module. So if it perceives low voltage, you're going to have issues like that. And sometimes the module's internal algorithms and electronics and stuff will report a voltage to the module's CPU that's not even accurate. Vehicle shows this wear. That's going to be positive camber. Look at that video. You can rewind and see that thing. I created that video. See, I got the whole control arm moving out, and that's an exaggeration. You won't usually see it that much, But I find myself sometimes just glancing at vehicles. I'm sitting behind a stoplight or something, and I'll see on the rear wheels, I'll see positive camber or negative camber, you know, one way or another. There was a lady's, and I had put some pictures of it. It was a red GMC, or Chevy Arcadia or something. It was out there at my dad's apartment, and there was a lady that lived in the apartment next to that, and I noticed she had a really bad positive camber on her driver's side front wheel because she had backed into the parking place, and I could just look over there and see it. And I says, "Does your vehicle pull to the left?" She goes, "Yeah, how did you know that?" And I says, "Well, that tire's leaning out if you look." She goes, "Well, yeah, it is. I never noticed that before." And she said she was going to get an alignment done. But, so you can see this. As a matter of fact, some people, the old, some of the redneck guys would use a carpenter's level, set it up so that they could hold it up against the rim with the vehicle, sitting on the ground, and look at that carpenter's level and tell if it had positive or negative camber like that. And then, a DIY, a sharp redneck would get up under there and make an adjustment, set it back on the ground and measure it again. The only thing that you can actually measure toe with a you center your steering wheel, make sure it's held solid, and measure your toe by you raise it up, spin the wheel, make a line right in the dead center of the tire all the way around it using a paint stick or something like that. And then you measure with a tape measure front of the tire, back of the tire, and then you adjust your tie rods so that both of those match. Now on rear wheel drive vehicles, you want it towed out slightly so it'll pull forward and have the toe right. On on rear wheel drive vehicles, you want it towed in just a tiny bit so it'll push those back. On front wheel drive vehicles, you want it towed out a tiny bit so it'll pull them forward some. And then there's, the road ground business going on. But anyway, you can set the toe with a tape measure if you're wanting to go to the trouble to do that. But they used to have, when I was teaching at the college, I had bought one of those, a stick with the 2 pointers on it that you could move and, measure it in front, move it to the back of it, and adjust it so they were front and the back were both the same. You got to have the steering wheel centered when you do it, though. Your steering wheel is going to be off, so make sure you do that. The only thing you can't really set with a yardstick or the tools you have at home is caster. The reason you can't set caster is because it has to be measured by turning the wheels back and forth 20 degrees, and that way it's measured. But there is a magnet device that costs about $500 that you can stick on the hub and turn it back and forth and get caster numbers that way, and it's got bubbles and stuff in it and all that. I had bought one of those and taught the students how to use that too. The shimmies felt at highway speeds, but the tires are balanced. A loose control arm will cause that. There's other stuff too. Actually, this loose control arm here was on a Ford Fusion that was making a popping noise, and it was the one that had the more than one control arm on it, as I remember. But it was a control arm like that. The lower control arm doesn't always look like an A-frame. See what I'm saying? But you can actually have, there's a bushing in here, and there's the ball joints out here. See how that thing's made? And that one there, I took a picture of that one because it was making a popping noise. So control arms can do all kinds of wacky stuff and all. EPS sets an overheat, and DTC most likely cause will be a binding steering rack. That is not terribly common if you do a lot of front end steering suspension work. You may run into that, and usually it won't be a steering rack like this. It's got the motor built onto it, although it can be. The ones that have the electric power steering unit up under the dash, right up close to the steering wheel on the steering column, they just got a plain old steering rack that doesn't even have any hoses or anything going to it. And if something happens and it binds up, it can cause the electronic power steering motor to heat up. But these are typically a belt-driven thing. They'll have a rubber belt in there. The ones that are up under the dash has got a worm gear that helps turn the steering wheel and that kind of thing. I actually had a picture of that in last week's test. Now this one right here wasn't too difficult. This toe out condition. You see these sawtooth feathered edges and then this ragged looking outside, it's dragging along here. I mean, whenever it's towed out and it's going forward, it's dragging that tire sideways while it's rolling, and that wears that out. And you can drag your hand across there and feel that, typically. If the tire's got cupping, it'll typically be because the shocks are letting the wheels bounce while it's, while it's going along. Question 9, vehicle nosedives excessively. Weak front struts, typically going to be that. Of course, most of the time you're going to have the thing is going to keep bouncing after it stops, or you can put your hands on put your hand on the front of it and start it bouncing, and then let go and it'll keep bouncing. And so, hope you enjoyed that. I created that from scratch, and this too, by the way. So, question 10. EPS vehicle steering does not want to return to center after turns. We talked about this last week. It's the same illustration I created for last week. When you're in the center, it's lower than it is at any other time. You turn your wheels to the left, it raises up a little. You turn to the right, it raises up a little. It naturally wants to return to the center. If you've got too much negative caster, which is what they do on vehicles that don't have, they make the caster more negative on vehicles without power steering to make them easier to steer without power steering. And if you've got one of those that doesn't have power steering, like an older car, like an old Mustang or something, and it's a little bit harder to steer, you might bring your steering a little bit more, your caster a little bit more negative for that. But caster provides that self-centered effect. Of course, we talked about last week, the EPS unit also will help with some of that. But think about this. If you've got a caster like a shopping cart wheel, right, or even one of the casters that goes on your office chair at home, and you're just pushing that along straight up like this. If it's straight up, this is going to wobble and turn around and do all kinds of stuff like that. However, if you take this wheel and let's say that it's got this post coming off the top of it, and you tilt that thing back so that it's an angle, and you can roll it, and it's going to stay straighter. See, that's another thing caster does, is it provides stability and kind of makes the vehicle want to stay straight going down the road. Now, that's just a sort of a simple illustration right there using that shopping cart wheel. That is the end of today's presentation. We've been here just over 17 minutes, and I hope you got something out of it. Let me know if this did you any good or not, and I'll talk to you guys next week.